Bell. Welcome everyone. So today we're going to talk about probability. What is probability? Last time we started talking about different types of variables. We said that if we have discrete variable or countable variable, we have a specific type of probability related to discrete variable. And also for continuous variable, you're going to work with different functions for probabilities. But before going over the variables in chapter 4 and chapter 5, where did probability come from? What are the basic terminologies and properties for a probability? So in chapter 4 and chapter 5, we're going to discuss these probabilities related to these two types of variables. Let us begin by a very simple example. In this example, I have a coin and I toss the coin. Experiment is tossing a coin. When we toss a coin, the outcomes are either head or tail. We don't have any other outcome, am I right? It's either head or tail for a normal coin. The set of all outcomes is denoted by sample space S, and we usually use parentheses, brackets, to represent all outcomes, head, comma, tail. So sample space, new terminology, is the collection of all possible outcomes. Collection of all possible outcomes. There you go. When you have a sample space, including all possible outcomes, there are some sub-collection or subsets for this set. S is just a set. This set has two members. Of course, you can define subsets for this set. We call them event. An event is a subset or sub-collection of sample space. Okay, very well. So for this set, how many subsets we have? How many events do we have? Well, you might say, okay, this is a collection including two members. The very first subset, A, includes just one member, which is head. The second set includes only tail. Okay. Not that bad so far. Another set, which is a subset of this set, is called empty set. It has no member in it. It's denoted by empty bracket. They call it empty set. And finally, the sample space itself forms an event. S equals to head, comma, tail is also a subset of S itself.
Do we not include the empty set in the overall set?
So the empty set is going to be a separate set. So you
Yes, but do we include it in the last one?
not here. You have
Got
1,
it.
2, 3, 4 subsets.
Got it. Thank you.
Yeah, sure. Thank you for asking. So I'm going to write down the formula for you. Here we have 4 subsets. Where does this come from? Note that here I wrote down for you, this set has 2 members. If you have a set, write it on top of the board here. If you have a set with n members, this is a set theory definition. Let set S has n members. So we say that the size of set S is n, or we say that the cardinality of set S is n. We say that the size of S is n, or the cardinality of set S is n, and we denote it this way. In different books, they use different notation. They say that, well, the cardinality or the size of set S is equal to n. This is the notation that they use to show that how many members are in set S. So for this set, the cardinality or size of set S is equal to 2. Well, if you know how many members are in set S, you can actually find the number of subsets for that set. For a set of size n or cardinality n, the number of subsets is 2 to power n. So if you have a set with size n, the number of subsets of that set 2 raised to power n. Okay, take a look at this. The cardinality or the size is 2. 2 raised to the second is 4 subsets. We expect to get 4 subsets. 2 of them are always fixed. One of them is empty set. The other one is the set itself. For empty set, you might see this symbol as well. Equals to O, the slash on it. So for empty set, you might see 2 different notation. But empty set and the set itself are definitely subsets of the set as well.
I have a question about the empty set.
Go ahead.
So, oh, here, I'll turn my camera on. So why do we like need an empty set if when you flip a coin, you're obviously gonna get like heads or tails? There's not gonna be a no outcome. So what is like the point of the empty set? What does it represent?
Very good, excellent. We're going to talk about probability of a set that has no, for example, a way to appear in that experiment. We need that. We need to have an empty set, which is representing an impossible event. There is a name for it. The probability of impossible event is 0. You're going to use this for the probability. So these are the new terminologies that you're using, the new definitions. Will this be posted for our reference? Yes, that's why I'm recording this.
Okay, thank you.
Of course. Good question. Great, everybody. So let us go over another example.